The FPGA Editor is used to add probes and make minor modifications to CLB logic, routing, and the IOB resources. The FPGA Editor is basically a tool for making small logic changes or adding probes to try and fix the design. Because you actually are editing the placed and routed design, you remove the need to resynthesize or place and route the design again when you make changes with this utility. But be careful, you're actually placing and routing the design manually, which means if you make a mistake, it's your mistake. So be sure to keep a copy of your last implementation result and then create a new place and routed design file after you're sure you didn't make any mistakes. After your changes have been made, you can create a new bit stream from the final NCD. The NCD, that is a native circuit design, which is the primary output of the place and route tools. Don't forget that any changes you make to your design with the FPGA Editor are not reflected to your HDL source code, which can be dangerous, so any changes should also be made to the source HDL. This utility is probably best used for adding probes and making short-term functional changes for in-circuit verification. The XPower utility is used to estimate the power consumption and junction temperature of your FPGA. Please note that this utility is quite accurate, even though it only shows average power consumption. It is very accurate because it reads from an implemented NCD file. That's your finished output of the place and route process. That means it knows all the routing and logic resources associated with your finished design. So when you provide activity rates, clock frequencies, capacitive loading, power supply data, and ambient temperature, it can calculate a very accurate representation of how much power will be used. This tool also allows you to supply a VCD file from your simulator, which can also help to supply design activity rates data. This helps get an even more accurate estimation of the average power consumption. This tool is included with the ASIC design suite, so there is no additional charge with its use. The Synopsys PrimeTime Static Timing Analyzer is a full-chip static timing analysis tool targeting complex, multi-million gate designs. PrimeTime provides for ASIC quality sign-off of multi-million gate FPGAs. This is a more robust static timing analysis tool than is provided by the ASIC software, and it provides an ASIC quality sign-off. Please note this is a third-party tool provided by Synopsys. In this module, we had a look at the differences between the ASIC and FPGA design flows. These flows were different primarily in that the ASIC flow requires much more verification and equivalency checking. We learned that the FPGAs don't require test logic to be added because there is dedicated JTAG logic and the FPGAs have already been verified, which also means that deep submicron verification is not necessary in an FPGA flow. There is also no waiting for prototypes with FPGAs, which means that firmware development can begin earlier and production to a finished product is completed faster. We also introduced a number of Xilinx utilities and software packages that are available. This includes the ChipScope Pro Analyzer software, the XPower utility, the Plan-Ahead software, the Floor Planner utility, and the FPGA Editor utility. We also mentioned that there are a couple of third-party equivalency checking tools you may want to consider evaluating. We also mentioned the Synopsys PrimeTime Static Timing Analysis software and its role in an FPGA design flow. Well, there are lots of places to learn more about FPGAs, and they all start at support.xilinx.com. To start with, you may want to review the Vertex 5 packaging and pinout specifications. This discusses design rules for PCB layout, provides pinout information, and other topics. The Vertex 5 configuration user guide provides more information on the JTAG logic resources and provides more information on readback. At the Education Services page, you will find information on the ChipScope Pro software course and the Plan-Ahead software courses we teach worldwide. I also want to mention that the Timing Analyzer utility is taught as part of the Designing for Performance course. Likewise, the FPGA Editor, Floor Planner, and Smart Guide utilities are explained as part of the Advanced Implementation course. Finally, I want to mention that the ChipScope Pro Analyzer software and the Plan Ahead software are available for a 60-day free trial. To take advantage of this, go to the software download page. Now, don't forget to start the coding conversion modules next. This will continue the comparison of ASIC technologies to Xilinx FPGAs. Again, my name is Frank Nelson. You've been listening to the FPGA versus ASIC Design Flows REL. Thanks for listening.